I believe we're live. Let us wait a few minutes for the people to join. Hello, hello, good morning. Welcome everyone. Let us wait a few minutes for people to join. Hello, welcome. I hope you guys are hearing me well. Can someone in the chat please confirm me that you guys can hear me? Oh yeah, awesome. Hello, hello. Let us wait one more minute and then we can start. Because we have a lot to go through today. All right, I think we can get started. What's up, everyone? Ohara here. I don't know if you guys know me, so this is a brief introduction. My name is Thiago Hara. I work at RDI Capgemini's group, and I'm here today to talk about C# LINQ. And I've been a software developer for over 14 years now, working mainly with C# and JavaScript and a bunch of different frameworks and versions across all these years. But I think this is it. In case you guys, it's your first time around this channel, please don't forget to subscribe, leave a like, share, and let's start. So today's topic is a little bit more of an intermediate programming topic. It's not as basic as some others that I've done in the past. So a few things are in order. First, I'll be using C#. So if you're not familiar with programming with C#, please feel free to browse the web for content. There's a ton of free content out there. And also any other this content it's more likely to be better understood if you already know how to code. So just to say it all out, to set expectations to everyone. All right. So what is LINQ? LINQ stands for language integrated query. And it's a net framework component to extract and process data from collections, any type of collections like arrays, enumerables, lists, databases, XML files, and other data sources. In simpler words, LINQ is a set of tools that allow us to work with collections more easily. For example, I've created here a small solution, a small program that loads a bunch of data. I generated some random data, and I'm using this JSON. So in here, I'll just execute this class is just for loading all this data and make this easier for us to, you know, create samples and samples for using LINQ. So whenever I run this program, I have essentially a collection with 100 employees with different data in there: names, phone numbers, companies, email, a bunch of other stuff. So the first thing I wanted to share with you guys is, let's say I want to filter out this list of employees. I want to select all the employees that have the age greater than 10, which should be everybody, but for example purposes, let's just create this function that would take the list of employees, and for each employee, it will verify if the age is greater than 10. So if I call this function and I pass my employees list, then I should have this function runs against a collection and filter out if there is any employee with age greater than 10, right? Find employee with age greater than 10. All right, so if we run this, we can see that the result is true. So we found at least one employee that the age is greater than 10. Good. Okay, now this is one way of filtering out this collection, right? So the main thing I want to talk about is LINQ. So we can do the same thing with LINQ, like this. So in the past, when LINQ was created, it was based on the type of query that we would write to SQL databases. So it has a language and syntax similar to this. If you guys are familiar with any database that works with SQL scripting, you will recognize this. So this is the way we would do the same filtering function, but with a LINQ. So we can, instead of calling this out, we can use this. And run and have the same result. or not. Yeah, now we got true. Okay, so this is how LINQ was created originally. So it's sort of bringing the query syntax from databases to inside the C# language. But today, I don't see this type of codes anymore. Today, when we use LINQ, we use mostly with lambda expressions. So the lambda expression is just a way to create anonymous functions. For example, I can write the same LINQ expression like this. By the way, I haven't asked before, but is this font size all right with you guys? You guys can read this, or do you want me to increase the font size? I hope you guys can read. All right. Someone has to zoom in a little more. Okay, let's try 200. Oh, my 200 might be a little too much. Let's try 180. Yeah, 180 seems good. Right. So this is what I was talking about, lambda expressions. So we can use this any function, which is a LINQ2, in order to filter out the collections of employees to see if any item of it has the age greater than 10. So this essentially is a function, an anonymous function, because it has no name on it. This is a much easier way to basically do this. All right. So this is what I see nowadays. It's a lot more. It's a lot easier. It's a lot cleaner. It's a lot more direct. It's a lot more common also. So this is what I see today. And if we do this, we should have the same. Oh, this is just a result. So if we run this, we should have the same true result. And here it is. All right, so this is the basics of LINQ. So LINQ is a set of tools that allow us to work with collections, all right? So we will go through a bunch of LINQ functions that I think they are the most common ones that I see around throughout the years, throughout the internet, and the most basic syntax and usage on each one of them, all right? Okay, so the functions that I want to cover today is any, all, count, contains, order by, sum, first, last, single, where, take, skip, distinct, and select. So the first function is any, which is the except the example that I already gave you. This function in LINQ, we can use it to determine if any of the conditions will be met. So in this lambda function, I'm verifying if the age is greater than 10. I don't care if the collection has more than one case, more than one employee that have an age greater than 10. I care if there is at least one. Okay, so just to clarify this anonymous function, let's rewrite it with more explicit syntax. So this is the same as writing this, all right? So we have anonymous functions that we have to return a Boolean expression. So I have to do this, age greater than 10. Even C sharp suggests me to turn this into a lambda expression, but this is basically what this means. All right. So okay, we cover any. The next one is the function all. Let me just get rid of this codes and this as well. The all function determines whether all the elements will satisfy the condition. So it's similar to the any, but instead of in the any function, if we have at least one case, it will evaluate to true. In the all function, we need every single case to evaluate true to the whole function returns true. In other words, this is the example I want to give you. Let me just make this more explicit. So on the employees, I want to see if every single one of the employees has the age less than 100. And this will only evaluate to true if every single one of those conditions is. Take a look at the data. So I have, the first one is 27, the second one is 24, and I have someone with 33, 32. So if I change this to age less than 30, this expression should evaluate to false because not everyone will satisfy this condition. So see, I should have changed the logging message, but you guys got the point. All right, we got the all function right there. So the main difference between any and all is that any will evaluate to true if a single case matches the condition, and all if every single case matches the condition. The next one is count. Returns the number of elements in the sequence. So I do have right here. It is essentially the array length. So we'll just return the number of items that we have in the collection. And it's pretty much it. There's no, it's pretty straightforward. Can run this. I have 100 employees in that data. All right, next one, order by. So order by is when we try to order our sequence. So let's take a look at our JSON again. So the first employee in my list is Stanley Gaines. He's a male at age 27, has no company, no email, no phone, has address, and whatever text on about. And the second one is Julianne Farrell, female, age 24. So let's say we want to order all the employees based on age. So this is 27, this is 24, so Julianne must come first and Sandy in the new sequence. first thing of this is this function, which is the order by function, is that it will not change the order of the original collection, but it will generate a new collection with the new order that you want. So let's create this ordered list and call this employees order by. Let me just see if I have resharper enabled, because I think this consumes a lot of memory and I'm not using right now. All right, so let's write a function to write the list. Otherwise, we will not see all the we will not see the ordered items. Employee to string. All right, so let me scroll up real quick. The toString methods, let me just, it has name, company, does not have age. Let's run this again. All right, so the first one is Walls Carter, age 20. So I know this might be a little small, but I hope you guys can see this. It is ordered by age. The younger one is Walls Carter with age 20, and the oldest one would be Prince Buchanan at age 40. Another, so there are a few key things to notice in the order by function. First, if I print out the employees list, it will have the original order. So the order by function creates a new collection. All right. So the original collection it maintains its state. The second thing that I really appreciate is that we can order by more than one field. So we can order by age and then by name. We just have to call this then by right after. And we can keep chaining this with multiple fields like company, right? Company. All right. So if I do this, it should order by age and then my company name. So again, these functions will return a new collection. This is important to notice, right? It's a very important detail. Okay, let's move on to the next function, which is sum. Sum is a little more, you guys might know this from maybe Excel spreadsheets, where we have to, totalize a column or something like that. So I'm going to create I'm going to create the sum of all employees' ages. Just for the sake of example. All right. So it will get every single age number and start adding up until we have a result. So the total years across all employees is 2,956. We won't see this type of function. We might see more in reports and stuff like that. All right, so we have a few more functions to go. Let's keep going. The next one that I have here is first. Very self-explanatory, but just to make it clear, it will return the first element of the sequence. Let's use result name. So the first one, it was, I don't remember, Stanley gains. So the thing that we can, when using LINQ, we can combine these functions. So let's say I can order by age, right? As we did before. And then grab the first element of this new list ordered by age, which should not be the Stanley gains. I don't remember the first one previously, but it will give us, if we run this, it was Carter. So yeah, pretty self-explanatory. The first returns the first element of the sequence. In the same way, there is a function called last, which will return the last member of the collection, which is Prince Buchanan. Buchanan, not sure which one. Okay, so the next one that I want to cover is single, and this one has some other details that I want you guys to pay attention. So employees single, it will return just the one element that will satisfy this condition. So in this list, let's grab the name Stanley Gaines. I've generated this list, this data, and there is no other employee named Stanley Gaines. So I'm going to filter out the single employee that is named Stanley Gaines. Console, right line, found employee named Stanley Gaines. Results. So we did find a Stanley Gaines. So here comes the catch. The single function, if we pass in a expression that evaluates to more than one result, this will generate an exception. So let's take, for example, if we filter out by age, let's say I want the single employee that the age that is 20 years old, has age equals to 20. But I know that the list contains more than one element with the age 20. So what will happen is that these functions will throw an exception because there is not a single element, there is multiple elements. There are multiple elements. So it throws in a invalid operation exception. Sequence contains more than one matching element. So this is what the first detail of this function is that if you pass in a function that evaluates to true in more than one case, it will throw an exception. And the other thing is that if I put in an expression that matches no element, it also will throw an exception. Sequence contains no matching element. So this is a detail of the single function. When you're using this, you must be sure that you're filtering out one that you want a particular element within the collection, right? And you sort of must know that this should be there. Otherwise, you want this to blow up an exception in order to don't cause any troubles down the line, down the processing of other things. Okay, so what if I want to filter more than one result? In this case, we have the where function. Let's I have an example here that's better written already. Okay, so I'm going to filter out all the employees where the gender equals to female. All right, so it gives me a list with all the female employees. Pretty cool, right? So we can, and also this also behaves in a similar way to the order by function. So the where function gives me a new list. So the original keeps its state. And we can add a bunch of different conditions here. So I could, just use the AND operator and maybe filter out by age less than 30. So we have just the younger female employees. All right, so we can see that the list has shrinked, and so on and so forth. Okay, so this is a very, very common expression, very common function that we use to filter out the collections. I'll still use this example because the next function, which is the take function, it will allow me to sort of slice a number of elements from within the collection, starting from the start of the collection. So we have here all the female employees. Let's just get back to the female without this. And I want to take only the first 5 female employees. It just returns the 5 firsts from the list. From this new list, not the original, but the new list. So they're only females and just the first ones based on the regular ordering. And we can combine this with, order by function. So we can just order by and, maybe by company, take 5. So it should give us a different list from before. Maybe we can, order by name. So okay, Ada Vasquez is the first one. So the take function, it will evaluate the collection, and from the starting position, it will take whatever number of items you pass in. In the same fashion, I will talk about the next function, which is skip, which allows us to literally skip the sequence of elements. So in our case before, let me just print out the female employees again, and I maybe can snapshot this so we can, just have a comparison. So first one is Julianne Farrell, then Pan Lopez, Lydia Woodward, Ashley Clayton, and so on. So if I use the function skip and I put in maybe 3, it will not return the Julianne Farrell, Pan Lopez, and Lydia Woodward. It will start with Ashley Clayton. It will skip the first 3 items of the collection. And like we predicted, Ashley Clayton is the first one. It's the new first one because we skipped the other ones, right? Okay, bear with me just a little longer. We are approaching the end. Okay, so the next function that I want to talk about is select. The select function is pretty cool actually, because it will allow us to, it uses the female collection. So let's grab the female collection. All right, let's say I first filter out all the female employees from the list, and then I want to work with a new data set. I want this data to be cast into a new type of object. So let's say I want the data to be anonymous, so names do not matter. And I also want to know if it has a phone number. So my new object would look like age, company, and just a Boolean value if the phone number is present or not. So in the way that we do this is using the select function, and within that we can create a new object and set all the properties that we want. So if you execute this, we should have an anonymous list that works, that has company, age, and if the phone number is registered or not. Right. So count as well. Yeah, we can use lambda in count as well. All right, so let's move on to talking about selects, and okay, the next one I have here is contains. So contain is another one that requires some care. First of all, I will use a different collection. So the collection that I want to use is just an array of integers. And I want to know if a particular integer is present in this collection. So the way to do this is by using the contains function, which will evaluate if this value is present in the collection. We have to be a little careful with this, and will explain why in a second. Let's just evaluate this, and it returned true because 27. Oh, it's not a prime number. So if we use a prime number like 11, which is present here, it should evaluate to true. All right. Okay, so what's the catch when using contains? Most of cases we might not be working with an array of primitive types, so we might be using, like we used before, the collection of employees, which are classes that we defined, and they are complex objects. So what happens if I write something like in order to check if this list contains an object or not, we must understand that the collections of objects in C#, they are not the value of the objects per se, they are just the collections of memory addresses where the values are held. So in order to do that, we need to get a hold of the reference to the object and then check if the object is present in the collection or not. All right, so this is something that we must be careful. So in this case, this Julianne Farrell employee is a new employee, is a new object, even though the data is the same that we have in the JSON file. When I evaluate this functions contains, because this Julianne is a new object, it does not matches the object that I have on the list. That's why we have this evaluate to no, to false. If I want to match the object, then I have to select the very same object that it is in the collection. So in here, I'm going to use the single function that we saw before. I'm going to filter out by name. So this will return me the object that is part of the collection, of the employees collection. And then I can check that the employees collection contains that object, which is kind of redundant, but just for you guys to see the difference where I have a different object, and then an object that actually points to the same memory address. So when using contains, we have to be mindful of this type of detail. Okay, bear with me just a little longer. We are close to the end. I have just one more function that I want to cover, which is distinct. And the example I have separated here is that first I will select all the ages, all the different age property from the employees list. So if I were to just print out this, so let's using for each var age in this collection console right line age tree string. So this should give us just a bunch of integers. All right, so we can see just a bunch of integers, and I can see here that a bunch of these numbers they are the same. We can even order this. Let's order by itself because there is no field, it's just a collection of ages. So we can see that we have 320, some other 21s and 22s. We have a bunch of repeated numbers. So the distinct function allows us to, select unique values. So on the ages collection, let's use distinct to get just the unique values from that list, and then we can do something else with this information. So we have people, employees with age 20, 21, 22, 23, up to 40. So we don't have any repeated numbers here. All right, we covered all the functions that I wanted. This is just the LINQ Basics. So I want to close out this presentation just by using an example that it's a little more close to what we will see in real life, in a real system, in real life coding. So, so I separated this exercise. From the collections of employees, I want to find all the employees that are males, have the age above 35, and the company property is null or empty, and the phone property or the email property is not null or empty. So let's say I want to, from the list of this list of employees, I want to filter out all the males above 35 that might be searching for another job, and I want to be able to reach out to them to maybe send a job position, a job offer, right? So how can we do this? Okay, so our results should be our list of employees, where let's start with gender male and age greater than 35, and here's the catch, because but not just yet. Let's use company. Company is a string, yeah, so I can use this string is null or empty in company. Let's break this into different lines. And I don't want, I want to have a phone number or a email. Cool. So here we have a list of male employees. We can, for each var employee results, we can console write line employee to string. Cool. I have 2 persons. But let us go a little further. I don't want to know who the employees are, so I want to cast this into anonymous employees. So what we do, we use select I want to select a new type, which will have just the email, phone, so just so I can reach out to them, and I want to start with the ones that are close to me, so I can order by phone. So this should give me just an object with email and phone. All right. Uh, so this is how we would filter out collections in more in a context more close to our real life. Another example is I want to based on parameters x and y, I want to create a subset of the employees list. I want to pick the first x elements of the sequence, and I want to skip y elements. So in order to do that, we saw that we can use the employees skip y, take x. I don't need to use to list here. And I can use for each employee result and just console right line employee to string. So let's skip 10 elements and grab 10 elements. All right. So this is the basic algorithm of pagination functions. So this is how pagination, in a very simplified version, this is how pagination works. You skip a number of elements and you pick a number of elements. So let's say in our page we want this should be number of records, and this should be the page. Should be based off the number of records multiplied by something, because the page as always needs to be a multiple of the number of records. But you guys got my point. So you would skip the page and grab the number of records, and this is how basic pagination works. So behind the scenes, if you see any sort of pagination, most likely we will have something similar to this. This is one of the examples that we can, use with LINQ. So we are very close to our time, and the last thing that I wanted to just let you guys know about LINQ is that LINQ also have data providers, which are data sources components that allow us to use specific data sources as our collections. For example, we can link to SQL. We have a link to SQL provider in order to work with SQL databases. And we have other providers like XML providers, link to XML, stuff like that to work with other data sources. If you are using this particular data sources, I would strongly recommend, because there are a bunch of small details and performance enhancements that they can do based on the data source that you're using. And also, some people, some of you might be, more senior developers and might be worried about Link's performance, which I don't blame you. It was a concern in the past, but the newer versions of NetCore framework, I'm gonna make this, it's only on NetCore, not touching the Net framework from Microsoft, right? Just the open source one. I think it's version 7 or above. They did a major performance refactor to Link. So it is very, very fast now. Okay? And I think this is it. You guys have any questions, any suggestions? Not sure if we have more hangout sessions into the end of the year. If not, don't forget to like, subscribe, share. Please leave comments, suggestions of any type. And if you guys don't have any questions, I think this is it. I wish you all a, Merry Christmas and a Happy New Year. And see you guys in the next one. Cheers.